Okay, this presentation is about what we can do with the new Gen AI regarding video, regarding video services, and regarding video technology, video distribution technology. As you know, Series21 is a streaming company, a traditional streaming company, and what we can do to help our customers to improve their content or to improve managing their content, okay? And so the story begins like a year ago when we found that transcription technology had improved a lot with Gen AI, and then there started to be a lot of open source transcription technology, which was quite easy to use. And so, as we're a video company, we said, okay, we may be able to easily take our streaming modules, put in between some transcription technology, adapt the output to learn how to work with subtitles and with transcriptions, and package those subtitles to the incoming video service, so that we output the same video service with the subtitles and with synchronized subtitles, okay? We look easy to do. We could reduce our modules. We could use an open source transcriptor, which seemed to work pretty well. We had to learn how to work with subtitles. And one thing we thought is, okay, we may need to delay the video signal in order to maintain the synchronization between the subtitles and the audio. Okay, but we're a video company, it was quite easy to do. We built this pipeline, everything seemed to work pretty well. We got to one of our customers and say, okay, let's do a test together. Everything was working, but suddenly we found that, we had a lot of problems. In between of the transcriptions, things like otro culo, otro culo, otro culo, otro culo, otro culo start to happen. We didn't even know what was happening. We didn't know what this was, but then we learned that they were hallucinations, you know, which mainly means that the Gen AI is doing whatever it wants. So, but besides this, we had another problem. We found other problems that at some point the transcriptor didn't work that well because, for example, when a speaker changed, the first sentences were not well transcripted. So we found on this first test that we had a lot of work to do. We refined the transcription technology, and we learned how to deal with hallucinations, and we improved our pipeline with this improved transcriptor and this hallucination detector. Okay, everything seemed to work well. This was nice. We had no hallucinations, and now we had the transcriptions, full transcriptions or almost full transcriptions all the time. We went to, so we decided to keep testing. We went to another customer, an event company that makes events for other companies, and wanted to add subtitles to the video. And what happens with these companies that before the event, they always start the streaming and put some music. And then, so with this music, we found that weird things were happening. The advertisements from other companies were coming into the screen. We couldn't even understand why was this happening. And then we learned that these models, these transcription models, are trained against a lot of content that's not properly validated. It's a lot of content, and so some of that content has been created by these companies, and they use the music to put the advertisements. And then when you train the model learns that with in some circumstances with music it has to output these kind of things. So we had a problem, a very a big problem. But besides this, we found that the voice of the music was usually not properly translated when it was at the front of the music. So it was a lead singer. It was quite properly translated. We didn't know if this was the best to have this translated or not, but okay. But if it was something like a core or something like this, then stupid words came out like gracias, no, and these kind of things. So we decided that we have a problem once again, and we have how to solve it. So we decided we knew that the transcriptors had a voice activity detector to avoid this problem, these problems. But as this voice activity detector is trained with at the same time at the transcriptor, it had the same bias, so it failed in the same moment, let's say. So what we had to do is to create our own voice activity detector, which we created from scratch because we didn't want it to have the same bias as the as other modules. The same. We didn't want to get a voice activity detector from other, let's say, transcriptor or that was currently trained, as we were afraid that it could have this. It could have been trained against the same content, and it could have the same bias. Okay. So we created our own voice activity detector. This was quite a tough work, but it worked pretty well, and we could avoid all these weird things that were happening on events when music came, when long periods of music. Everything improved, and so we found everything was working quite properly, but we found smaller errors that, for example, the specific domain language. So these transcriptors are trained once again against a lot of content, existing content, but this content usually doesn't have the information, specific domain information. So when it comes, for example, to the football stadiums in Spain, it didn't wrote them properly. Okay. While when it comes to Mbappé, which is very famous, is okay. It could be a specific domain name, but it's very famous. It doesn't care. You don't have to care how the person pronounces Mbappé. It will always write it properly. Okay, so for this we created a domain-specific dictionary, which is mostly something that when it finds what you have, when it finds a wrong word that you have specifically written there, it substitutes, it replaces this word by a correct word that you have as well written there. So there is a table of good and bad transcriptions, okay, to substitute one against the other. This worked pretty well. It gives you, it improves, clearly improves the experience. So we seem to be improving again, which is nice. And then we got to the point that that subtitles. Right now, what do companies want subtitles for? Subtitles now are considered like a tool to wider the potential customers that can use content. So, but this is mainly because you can have subtitles of different languages, easily create subtitles of different languages, so that people from other countries can see the content even though they don't speak the language of the content, okay, easily. And we went there and we found it, we went to a SaaS API, an external API, Google and Amazon and so on, and we found, and everything worked pretty well, in fact, but we then found small problems, but weird problems. Because this is a true, this is a true example. It happened in one event. They were talking about a joint venture, and the translator translated it as a porro. So, because they just say a joint, okay? It's a possibility to take a joint, to take on a joint, but we can see. And he said, es una posibilidad hacer un porro, pero no lo vemos. This is a problem, of course, but we had another problem, which is that when you are translating to five or six different languages, and you're using an external service, the cost increases a lot, so your margins reduce a lot as well. And this was a problem to commercialize the technology, okay? And so what did we do? We created our own translator technology, for which we tested a lot of different technologies, and we refined those technologies, and which lowered the cost a lot. So it increased our margins and to a reasonable amount. And we took the translation technology that we found that that was better, but we also found that it could handle better the context of the translation. So joint, it was not translated as a porro anymore. It was translated as a shared project, or un proyecto conjunto, okay? We also added a blacklist because with this porro, we thought that this could happen at any time, that there can be something about transcription or about translation that can take us to these kind of situations. So we added a blacklist, which is a list of offensive words that should be replaced, but this is changed, but okay, by asterisks, okay. They say, okay, this is not a good one. Okay, and how did we do this translation technology? Because it was quite difficult. It took us a lot of time. We selected different technologies. We made automatic benchmarks to test them, and we started a cycle of refining, benchmarking for different languages, for the most common languages we use. Okay, so these are the graphs of 5 technologies for English, Catalan, French, and Galician. Euskera is impossible to handle, so we don't have it. And if we need a language that we don't handle well, or we don't know if we handle it well, we go for external API for that language. Okay. Okay, and so we almost had our transcription pipeline finished. What we were missing the serialization, which is speaker segmentation or speaker separation, on which you can say, okay, this was said by speaker 1, this was said by speaker 2. We don't identify the speakers, even if we have a previous content of that person, but we identify if this is the same speaker as before, and this is the same speaker, the other same speaker as before, let's say. And with this, we finalized the transcription pipeline, which we have now on production, okay? On which we don't create subtitles, but we create high-quality subtitles. Okay, so once we had these transcriptions, high quality transcriptions and subtitles, we thought that using an LLM, if we put all this information that we're transcripting in an LLM, we could extract some metadata that could allow our customers to manage, to easily manage their content. Okay, so we started with a list we checked what made sense to have. We started with summary, highlights, which is the most important moments of a program, let's say, the summary of a program, highlights of a program, entities, which are the most important subjects of the program, classification or indexing of the content, which now we're doing it according to the recommendation EVU Tech 3322, I think it is, so to a recommendation from the EVU, and you can say, okay, I classify against the recommendation of the EVU. and we extract the sentiment as well. We had this idea, we started working with this. Working with LLMs is just, you ask, it answers, everything is nice. But we found once again that working with that prompting is difficult. So when you are interacting with an LLM, you ask, it answers, and if it's not the exact answer, you re-ask and it re-answers. But when you're automating things, you don't have that opportunity, that second opportunity, let's say, or you don't know when the answer is correct and when it's not correct. So prompting is difficult. We found different problems. It has hallucinations as well that we almost knew how to deal with because of the transcription. It also has the problem that, which is an hallucination as well, that it invents the response depending on with previous knowledge that it was trained. So this is an example. This is a real example. It's difficult to read, but the thing is that there was no input, so there was no transcription, and we asked to give us a summary, the LLM to give us a summary of the program, and in fact, it gave us a summary of the program, of a program that didn't exist, of a program in which it had no information, okay? And this is also difficult to handle. So at the end, you have to identify good responses and be able to select good responses and to throw away bad responses. You need to identify wrong formatted information. Sometimes you want a list, but it doesn't give you a list. You want a plain text, but it gives you bullets. These kind of things is quite difficult. And you have to work around in prompting. Prompting is difficult because LLMs handle tokens, we handle words, and word-to-token representation is not perfect, okay? So at the end you have to find the combination of words that match, that gets you the best combination of tokens and makes the LLM work properly, okay? And then there are weird examples, like if you tell an LLM that you will pay it a tip if it improves the answer, it usually improves the answer. So this is crazy. You don't know what's happening there. But okay, we got our technology. It worked. It's pretty stable. So we were able to avoid this kind of problems. And we got we added hallucination detector, information validator, format validator to make all this work properly. And then we thought that, okay, we may be able then to create a chat on which the user can interact with it with their content. The users can interact with their content, which also seems when you chat with ChatGPT, it seems easy to do, but we found again a lot of problems. What problems did we find? We found that the context of the LLMs is somehow limited. What does this mean? This means that you cannot input the text of 1 hour of television to one LLM and then ask the LLM for what happened at the beginning. It probably had lost that information. It doesn't have that big context, okay? And so we had to take this context to group this test of the information we wanted, the information that was transcribed. We had to group it in by context, so that all the information in the same context is in the same group, but none of if the context changes, then you have to start another group. Take these groups, vectorize them, and create the embeddings out of them, so that we have context embeddings, good context embeddings, and use retrieval augmented generation algorithms to retrieve the content that we wanted to search. This was the following way. The user makes a query. The query, we create an embedding out of the query, and then we go to the database and select as we had taken all the information grouped by context and vectorized in the database. We go to the database and we select the embeddings that are most similar to the embedding of the query. We get those embeddings, we get the text information related to those embeddings, and then we go to the LLM and said, okay, answer this question with this information that we have retrieved from the database. But then, as you can see, the process is much complex. And in fact, the process is much more complex than this, okay? So just checking the similarity between embeddings doesn't properly work for it. You need complex search algorithms, and there's a lot of query misinterpretation. So if the query is quite complex, it will probably answer the first part, but not the second part. These kind of things that you have to, we have had to solve, but at the end, we solved it, and everything worked. So now we have this full pipeline where you can transcribe, create subtitles in real time, in non-real time, create metadata to index the video, and to work with the catalog for the customers, for broadcasters, and so on, and they can as well search in a chat, as if a chat GPT was. This is already working in some of our customers. It seems to work pretty well. And this is the status of our technology today. Okay, and so what comes next? So right now, what are we working on? Now we're working on adding video capabilities to this system. Okay, so that we can create image to text, video to text. Before of that, we can identify the people in the images or the brands in the images and take it to the image to text and mix it with the image to text and video to text, so that we can describe not only the scene, but the people involved and the brands involved as well. We are making embeddings from the visual embeddings, the same way that we were creating text embeddings here, taking them to the vectorial database to be able to process them in this retrieval augmented generation, and so be able to include them in the whole pipeline for the summaries, for the highlights, and for everything. Okay. We're working very hard in detecting the boundaries at different granularities of the content. For example, we want to detect where a program starts and when it ends, but we also want to detect when for example, in the news, when one of the news is starting and when it's finishing. So because we may be we may want to make a summary of all the news, one after the other, or we may want to make a summary of the full program, okay? These kind of things are very important, because if you mix the information, then the summary is not that good, everything is not that good. We're working in automatic clipping of the highlights. So when you have a program, you can extract the highlights, as we do here, but you can extract in text, okay, and in time, but you can also extract, create a clip out of these highlights. And we are creating video summaries as well by using highlights, segmentation. So yeah, we are now starting to create like higher level tools, okay? And at the end, we are adding speaker detection or speaker identification, so that when, if we have previous knowledge and previous samples of audio of one speaker and who he is, to be able to detect him and knows not to say this is speaker one, but this is Pepito or this is Pepita, okay? So this would be supposed to be our next version of the system after hopefully we'll be able after the summer, and after that we will try to work. We're looking at personalization for different use cases. This is mostly related with this specific domain language or a specific domain identification of persons, okay? So that we want to, if we have 1 year of transcription which have been corrected and which are better, high quality transcription, then we can fine tune the transcriptor and take this and improve its performance in this use case, okay? So if we have been transcribed, let's say, MotoGP for one year or football for 1 year, at the end we will have very good transcriptions, and we can fine-tune the transcriptor to be very well for the Spanish football, let's say. Okay, we want to do the same with the image-to-text technology and with the video-to-text, and probably with LLMs. This is another battle. This is much more difficult, much more expensive, and so we have to see if it makes sense. Okay, and after that, where we would like to go? We would like to go to multimodal systems. This is not very beautiful, this slide, but anyway, multimodal systems are coming. ChatGPT, the last ChatGPT is multimodal. It can tell you what's in the camera, what's in everything. So at the end, as we expect to have just one model that we can fine-tune, we can retrain, and we can just request it most of the things that we are doing with many modules right now, okay? But, okay, this is for the long term, but sometime it will come. Okay, now we have a demo here of these automatic subtitles on which we're using. Here we're using the voice activity detector, and we're using the domain dictionary. So you will see most of the names are okay, or almost all the names are okay, and it is synchronized with the speaker. And the experience is very good. Oh,
I don't know if it's
no speaker.
No.
Class winner here today.
That's, yeah, you didn't expect that.
Well, I didn't expect that either. But
Sensational start from the middle of that front row. He will lead the field into first corner. Here comes Bastianini. Raced for here a couple of years ago. Viñales gets properly barged by Bagnaia in the first corner. The pole man's outside the top 10, but it is Acosta that leads.
it was three abreast through turn one. It was Bagnaia and Martin side by side, and Vinales on the outside got squeezed out wide, somewhat straight across the run-up in the background. I don't know whether that wasn't a Aprilia, but the gas KTM leads Acosta from Bastianini and Martin.
Absolutely nailed the start, didn't he, Acosta? Marc Marquez came through the first sector in 5th place. Martin wasted little time in finding his way through on an air Bastianini through.
Okay, that's it. And okay, and just ¿cómo muevo esto? Okay.
By his name in the history.
Okay, and this is an example of the metadata. Okay, on which some of the metadata. Sorry. No, esto se ha quedado flipadísimo. Aquí.
Empresa aquí, increíble.
¿Qué pasa aquí, tío?
Es el chiringuito.
Okay. Okay, this is an example of metadata. So here you have the entities, for example. Here you have the transcription, which you can switch languages here. Here you have a summary of a program. It says, este programa se centra en temas políticos y sociales en España, abordando la seguridad social, la educación, la sanidad y la amnistía. Se menciona una nueva cobertura, tal. And this is a search, which you have the question, and you should have the answer here, which is no is loading. But we not only give the answer, but we only give the fonts that we have found that were related to the answer, and the timing in the content, so that people. So that the user can go and check the content and clip it or work with it whenever it wants. Okay. Well, just a bit about the philosophy we're applying to this system, to this product. Okay, we want to work in the future. We want to work in personalization as we want. We think that we can have personalization for a few different use cases. We will make at the end our technology more generic, better in general. Okay, we work a lot in what we call expert systems, which are not the main functionalities like transcription or summarization, but are what improves the functionalities. For example, the voice activity detector, the fine-tuning, the hallucinations manager, the expert translation, and so on. And we are going to an efficient AI architecture to make a SaaS product, to be able, making a SaaS product, to be able to offer it to the customers in the best and easiest way. Okay, and this is some acknowledges of the people working, the outstanding team actively working on this work. It's great. They have done a very good work, and just if you don't have an outstanding team like this, just talk to us. Don't try to make it yourself. Okay. Okay. Thank you. This is the end. Thank you.